This presentation will review the Georgia Standards of Excellence 2 MBT6, which states that students will add up to 4 two-digit numbers using strategies based on place value and properties of operations. Success with 2 MBT6 is closely related to 1 MBT4 and 2 MBT5, where students add within 100 using concrete models, strategies based on place value, and the properties of operations. The focus is on conceptual understanding without the use of standard algorithms and procedural steps. To learn more about the vertical progression of addition and subtraction from kindergarten through 4th grade, please check out Graham Fletcher's video that is referenced below this presentation. As the standard states, students will use place value understanding and properties of operations to add up to 4 two-digit numbers. In this example, students were asked to add 43 plus 34 plus 57 plus 24. The first student decided to add the 43 and 57 first to get 100. They then added on from there. The second student used place value understanding by first adding the tens and then the ones, while the third student used a combination of both strategies. After decomposing the numbers into tens and ones, they then changed the order of the add-ins to make adding easier. While it is not important for students to memorize the names of the properties, it is important that they understand how each property works. When using the commutative property, students can rearrange the order of the add-ins and still get the same sum. And with the associative property, students can group add-ins to make adding easier. 4 plus 2 equals 6, plus 1 more equals 7, which is the same as 4 plus 3. Here are a few examples of how place value understanding and the properties of operations can be used when adding a series of numbers. In this example, the student wanted to determine how much they spent when they went bowling. They spent $3 on shoe rental, $14 on bowling, $6 on snacks, and $12 at the arcade. How much did they spend in all? When adding up the series of numbers, the student noticed that 14 plus 6 could make a friendly number, or 20. They could then add 3 plus 12 to get 15. By decomposing the numbers into place value, they can add the ones to get 5 and the tens to get 30. The total amount spent was $35. In this example, the student is determining how much money they need to spend in order to buy all of the pet supplies. The student used place value understanding to decompose the numbers into tens and ones. They then used the associative property to group the 10 and 40 together to make 50. 50 plus 50 is 100, plus 20 more equals 120. The student then added the ones together. 9 plus 7 plus 5 plus 3. Again, the student used the associative property to make a 10. They then added 9 plus 5 to get 14. 14 plus 10 is 24. 120 and 24 are the partial sums. 120 plus 24 equals 144. In this example, the student used a variety of different strategies to determine how many students came to school. The student first grouped 79 plus 21 to make friendly numbers. By adding 1 to 79 and by taking 1 away from 21, they were able to create 80 plus 20, which equals 100. The student then decomposed the numbers into tens and ones. 100 plus 90 plus then 8 more equals 198. Regardless of the strategies used, students should have access to a variety of concrete manipulatives before moving to the abstract. Let's take a look at some additional games and tasks that can be played in the classroom. In closest to 100, students take turns picking a card. They then use strategies to place each digit in a location that will allow them to get closest to 100. In this next game, students cover 3 or 4 numbers on their game board and then add up to find the total sum. In the upcoming videos, you will see how students use place value understanding and the properties of operations throughout the task.
That's 3, 30.
30.
1.
Well, is that a 1 or is that a 10?
That's a 10.
Okay, so we have 30 plus, or you want to add your tens first? 20. And now, what are you going to add?
Ones.
The ones. So what's your final sum? If we put all our tens together.
Could be 50, 52.
So how did you know the sum was 140?
Because I added 90 plus 10, which took both of those numbers, but it made 100. So then I added 100 plus 27, because here was 27, here was 100. And it equals 127. So then I plus 127 plus 13, and that equaled me to 40, and 140. And that's how I got 140.
So how did you add your numbers together?
So I regrouped these to make a friendly number, and they make the 100. And then I did the same thing with that, and then I made this.
So how did you get 90?
90. I regrouped 4 and 5.
Is that just a 4 or is it a 40?
40.
So you added 40 and 50 to get 90, and how did you get 12?
So I added 5 plus 7 to get 12.
And so how did you get 190?
Oh, that's easy. So I added 190 together.
And then when you have 190 plus 12, the sum is 202. As students move to representational and abstract thinking, open number lines can be encouraged. In this example, the student created 4 add-ins. He then rearranged the add-ins so that he would start adding from the largest number. After placing 59 on the number line, the student then decomposed the remaining add-ins into tens and ones. 30 plus 20 plus 10 equals 60. So what would you add next?
So I'll take the 8 and take 2 out of 5. So that would be 3, and then the 8 plus the 2 would be 10.
Okay.
So a hop of 10. And then left out numbers is 3.
So you broke apart the 5 into 2 and 3 so you could make a 10?
Yep.
So what is the sum of all of your numbers?
132.
2 MBT6 leads itself into multiple opportunities for real-world application. To practice adding a series of add-ins, students created wish lists using book order forms as well as designed their own menus for a restaurant of their choice. These hands-on engaging tasks motivated students to succeed. Playing restaurant allowed for small group peer interaction and discussion as well as feedback.
Yes, I would have 2 raspberry scroll cakes for $12 and 1 lemonade with whipped cream. I say this is $11 and that's all.
So what's her total?
I know that 12 plus 12 is 24, so 24 plus 10 equals 34. 34 plus 1 equals 35, so her total is 35.
The book order wish list also offered a real-world context that motivated students to find the total sum after selecting their merchandise. In this example, the student showed true number sense by grouping the 11 and 39 to make 50 and the 12 and 18 to make 30. And this student used an open number line to add up by tens and ones. So how much do your books cost?
27 plus 27 plus 9.
And how can you find the sum of 27 plus 27 plus 9?
I can think of quarters and take away 2 from these 7, and I can add those. 25 plus 25 equals 50. 50 plus 13 equals 6.
And how did you get 13?
I got 13 from these two 7.
So the 2 plus 2 plus 9, okay? So your total cost is $63. Lastly, students can pretend that they are shopping for their pet and develop a list of needed supplies. How much will the supplies cost? So what does your cat need?
Toys for 21, food for 20, and bowl for 9, and a bed for 22.
Okay, so what strategies did you use when adding up to find the total cost?
21 plus 9 equals 30, and 22 plus 20 equals 42.
Why did you put the 21 and 9 together?
Because that would make it easier to make 30.
Yes. And so what's your total cost? 30 plus 42 equals?
72.
For additional support and resources, please check out Unit 4 in the Georgia Frameworks, along with the correlating videos on addition and subtraction strategies.